Hello beautiful people, Miss Beeching here. In this skill we're going to look at applying two different skills together. We're going to look at the words if, given, and, or, at least, at most, and not, these ones here. And we're going to apply them to Venn diagrams, two-way tables, and tree diagrams. So there's not much new stuff in this skill, we're just learning how to combine our knowledge from two other skills together. There are two little bits of vocab or notation that we haven't looked at yet though. And they are, and I'm going to mispronounce this probably, but the Greek letter xi. It looks like this crazy little squiggly do, and if you're thinking, how the heck am I going to draw that? Don't stress too much, like, I don't really draw it super well. As long as you get the rough kind of backwards 3 and then a curly bit down the bottom, I think you're pretty good. So this Greek letter xi represents the full sample space. And so we could say, like on a Venn diagram, if this is our two, event A, event B, then we would draw xi here, badly drawn, to represent that this box encompasses the whole sample space. It just pops up occasionally in the notation, but it's nothing too important. And then if we write something as n with an event in the brackets, that's saying the number of elements, hence n, in the set specified. So if I said n a, I'm saying the number of elements in event A. And these are just two bits of notation that'll pop up as we're doing this skill. Here we've got a Venn diagram and a set of Venn diagrams, just showing the different notations that correspond to it. You've already looked at different Venn diagrams, coloring them in a few other skills. Here we're applying it to the notation specifically. Usually you'll see things like intersection or and, union or, and complement or not on Venn diagrams. Generally those are the main notations that pop up because Venn diagrams are all about what is there, what's not there, what's both there. So if we quickly look at the notations on this diagram here, you'll notice this xi over here representing the sample space. And then this part here is showing that this part of the Venn diagram on the outside is not A and not B. Okay, and then this part here, which is shaded this part, that is not A and B. So it's all the parts of B that are not A. And then we can do the same thing on the other side. So this section of the Venn diagram is A and not B. So it's all the parts of A that aren't part of B. And then of course this part in the middle is A and B. So it's all the parts that are A and B at the same time. Whoop. And you can kind of see it a bit more clearly here with the different words. So we've got A and B colored in, A or B, not A, so that's a complement. So you can see that everything except for A is colored in. And then here's another little fun one, and we can write it either with brackets, with a dash on the outside of the brackets, or we can write the dash separately on each of these. And this says not A and not B, or A or B, not the whole thing. And that just represents all of this shaded area that isn't part of A and isn't part of B. We can also have more complicated ones on bigger Venn diagrams. You'll explore some bigger Venn diagrams in this skill. So say we had one that has 3 circles, and for these I'm not going to show every single possibility, it would take forever. But just to give you an example, and if I put my little xi, my terrible xi here, say I wanted to describe like A or B and not C. First thing I do is I group the and together. It's kind of like saying with order of operations A plus B times C. So we're always going to group those ones with and. And so B and not C would be this area here. And we're also saying or A. So we're going to include all of A. And some people might be thinking, whoa, why are you doing this area here? This is one item, B and not C. That was that first part we shaded. And the or means that we can include all of A, right? Even if it's not part of C, or even if it is part of C. And let's do just one more example with this three-pronged Venn diagram, three-way Venn diagram, however you like to call it. A, B, C. So we could say something like not A or B. I'll keep it a bit simpler this time. So we're saying, okay, here's all the parts of not A. It's like literally everything that's not in the circle of A. And we're also saying or B. So we're going to include everything that's part of B as well. So now we also include these little sections here. So that would be not A or B. I'm not going to show you every possibility in this video. You need to apply your logic to work out which parts to color in there. Here we've got a two-way table. The information you'll see in a two-way table is pretty much the same as a Venn diagram because two-way tables show the same information as Venn diagram except with these extra totals included. So this just gives you a really quick and dirty idea of like here we'd write either probability of A and B because A and B cross over in this box. Or you could also have a two-way table that instead of saying the probability here, it could say the number of A and B, how many outcomes fit in here instead of the probability, which is what you guys are probably a bit more used to if you've only been working on the 1 point something skills so far. And then say like this one here is not A and B. So here's not A, here's B, this is where they cross over. And then for the totals, say like this one, this is not A because not A is over here and it's the total added up across. And then you might see that Xi has showed up again because this is the total of everything. So the probability of everything in the sample space is 1 or 100%. Okay, here we have a tree diagram. Generally, tree diagrams are really helpful for also showing given events. So you'll see here we've got the notation for given that. And they're really helpful for that notation because you can kind of see what happened in the branch beforehand. So here on this branch, we've got the probability of A happening. And now that A has already happened on this set of branches, we can say, all right, well, this is the probability of B given that A already happened. Or on the other branch, probability of not B given that A has already happened. And you could apply the same logic to the other set of branches. So we could say, okay, here's the probability of B given that not A has already happened. And of course, the probabilities on the branches are just for that particular thing. So then over here, we've got the different outcomes. So we've got A and B, because those are the ones that happened in a row, or A and not B, or not A and not B, because not A happened and then B happened, and so on and so forth. We're not going to use the notation a huge amount for tree diagrams, but this is really helpful for other skills later on in column 2, where you're going to be talking about given that probabilities. If you understand all that, that's fantastic. I'm going to do 1 or 2 more examples of these three-way Venn diagrams because people find them quite tricky. If you understand, you can finish watching this video and be on your merry way. If not, stick around and we'll do just a couple more. Particularly because a lot of people get confused between and or. So I'm going to show the difference between an and an or. So if we've got A, B, C, A, B, C. So if I said not, actually I'm going to go A and not C versus A or not C. All right. So if we're saying and, it has to fulfill both criteria at the same time. So there's only sections that are included in A's circle and not included in C's circle. So that would be all of this. The parts of A that aren't part of C. Okay? Very different when we talk about or, because we are saying it could be either. Think about and as both. Think about or as either. So it could be A, so we're going to color in all of A, or it could be any part of not C. So that's literally any part of the Venn diagram that is not part of the circle that is C added onto that. And you can kind of see how that works like addition, like I mentioned earlier, and this kind of works like multiplication. That's it from me. Good luck with this skill. Let your teacher know if you have any questions, and I'll see you next time.